Hello, welcome Algebra 2 Trig students. Today we are going to learn about motion problems. And they, in general, use this formula here, distance equals rate times time. So there's really three ideas you have to keep in mind when you're solving a motion problem. You have to know the basic formula should always be used. Rate times time equals distance. And you have to determine if the described distances in the problem are equal to one another or if they equal a third distance. So that will guide the equation that you set up. And then the third thing you have to be certain of is that when you have time involved, it's the same unit of measurement. So if a rate is given in miles per hour, then the time unit has to be in hours. So you have to make sure that those are consistent. Another example would be if the rate is given in meters per second, then time must be in seconds. So in the simple example above, you can see if Juan drives a vehicle at a constant rate of 63 miles per hour for 2.5 miles, how far will he drive? Confirm that your time is in the appropriate unit, and it is. And then if we want to know how far they went, all you have to do is plug into this formula. Distance equals rate times time. And the rate here is 63, and the time is 2.5. And then you multiply those two, you get 157.5. And the units are important here. How far did Juan go? He went 157.5 miles. Let's look at a more complicated example. So, a radar detected an unidentified plane 5,000 miles away, approaching at a rate of 700 miles per hour. 15 minutes later, a defender plane was dispatched traveling at a rate of 800 miles per hour. How long did the interceptor take to reach the approaching plane? Okay, so whenever I do these problems, I like to fill out this chart. It just helps me organize my information. So my unidentified plane was going at 700 miles per hour. And the defender plane was going at 800 miles per hour. And we'd like to know how long it took the inceptor plane to reach the approaching plane. So I'm going to make that my variable for time, because then once I find that, I'll have the answer to my problem. Now, let's go back and read here. 15 minutes later, a defender plane was dispatched. That means my unidentified plane has been flying 15 minutes more than the defender plane. So I'm going to make the time that that unidentified plane was flying t plus, and be very careful here. It's not 15, it's 1/4, because remember, we have to make sure that our units match. This is in miles per hour. Time must be in hours. So 15 minutes is 1/4 of an hour. Now, the distance my unidentified plane travels is 700 times the quantity t plus 1/4. And the defender plane is going 800 miles per hour times t. Now, we have to determine, do I set those distances equal? Do they sum to a third quantity? Well, the key here is that unidentified plane is 5,000 miles away. So I want you to imagine this unidentified plane is approaching this direction, and then I have my defender plane approaching that direction. The whole distance between the two starts at 5,000 miles. That means that if I add the distances each travels together, it should be equal to 5,000. So the equation in this case would be 700 times t plus 1/4 plus 800t equals 5,000. So now at this point, what's left is to solve for t. I'd like you to press pause on your video, solve it, and then press play again so that you can check your answers. Here's the answer that you should have gotten. So 700 I distributed inside. and got this line. Then I combined my like terms, and then I subtracted 175 from both sides, and then I divided both sides by 1500. Now remember, the units on time are hours. It's 3.22 rounded hours. Well, usually we don't say 3.2 hours. We usually put things in hours and minutes. So I know there's there are 3 hours and then some number of minutes afterwards. So from my result, I subtracted 3, and then I multiplied the remaining decimal times 60 because there are 60 minutes in every hour. And I found that I had 3 hours and 13 minutes. So it took 3 hours and 13 minutes for the inceptor to reach the approaching plane. Now be very careful about all of this. You've got to make sure that your variable represents the quantity you're supposed to find. If I had made the unidentified plane's time t, in order to get my answer, I would have had to subtract 1/4 of an hour from that. Take a look at this problem and give it a try. Remember to be very careful about the units. Press pause on your video, and when you're ready for the answer, press play again. In this example, we have equal distances. So let me talk about how I set it up first. Clayton drove to Mackenzie's house where an Algebra 2 study group was happening. The trip took him 20 minutes, while the trip home took him 5 minutes less since there was less traffic, which allowed him to drive 10 miles per hour faster. How far apart do Mackenzie and Clayton live? Well, taking this a little bit at a time, I don't know the rate. So the rate to the trip from home, I made X. And then the trip back, he was able to go 10 miles per hour faster. So this cell, I made X plus 10 miles per hour faster. So my rate is in miles per hour, which means the time has to be in hours. Well, the trip there took him 20 minutes. So you can see I had to convert minutes to hours. I did that by multiplying by 1/60, and that's 1/3 of an hour. So that goes there for time. And then the trip home, he did in 15 minutes. So again, I converted this to hours by multiplying by 1/60. So that was 1/4 of an hour. Now remember that rate times time equals distance. So X times 1/3 would be my distance, the trip from home on the way there. And the distance on the way back would be, again, my rate times my time. So 1/4 times X plus 10. Remember, X plus 10 has to be in parentheses. Now, since we are traveling, Clayton is traveling to Mackenzie's house and back, those distances are equal. So now we set them equal and we solve for X. And we find that X is 30 miles per hour. Now be really careful about what you're answering. It says, how far apart do Mackenzie and Clayton live? Okay, well, I'm not looking for 30. That's the rate. So the distance is 1/3 times the rate. So they live 10 miles apart. Now let's try this one together. We have 2 buses that leave the bus depot at 3:15, traveling in opposite directions. So here's my bus depot. One is traveling one way while the other is traveling in the opposite direction. The bus headed north averages a speed of 55 miles per hour. So we're going to put that here. While the bus headed south averages 45 miles per hour. At what time will they be 400 miles apart? So we're looking for a time when their total distance, the sum of their distances, is 400 miles apart. They left the bus depot at 3:15 p.m. and they both left at the same time. So they will be driving exactly the same length of time. So that is, I'll just make t the time length for both of them. And again, my distance is equal to the rate times time. So this distance is 55 times t, while the southbound bus distance is 45 times t. Now we're looking for the time, not the amount of time, the actual time when they'll be 400 miles apart. So we're going to add these two together and set it equal to 400. So that would be 45t plus 55t is equal to 400. So now we'll combine like terms. 45 plus 55 is 100. So 100t equals 400, and then divide both sides by 100. So t equals 4. Remember I said, what time will they be 400 miles apart? Well, they'll be 400 miles apart 4 hours after they start driving. So they will be 400 miles apart at 7:15 p.m. Okay, try this one. Press pause on your video, and when you're ready for the answer, press play again. So let's talk about this one. Hope runs 2 meters per second faster than Quinn. If she gives Quinn, who runs at a speed of 10 meters per second, a 20-second head start, after how many minutes, notice I circled minutes, will Hope overtake Quinn? Now, the reason I underlined Hope here is I want to know how long Hope has to run to catch up to Quinn. So since that's the question, I'm going to call my variable t the length of time that Hope runs. Well, she gives Quinn a 20-second head start. So Quinn is running 20 seconds longer than is Hope. So this is t plus 20. Notice that my rates are in meters per second. So Quinn runs at 10 meters per second. So my time is going to be in seconds, which makes it appropriate to add the 20 seconds to the t. And Hope runs 2 meters per second faster. So she runs at 12 meters per second. I can find the distances by multiplying rate times time, so that's these. And because Hope is catching up with Quinn, that means that they're going to be running the same distance. So I set these equal to each other, distribute the 10, then I subtracted 10t from both sides, and then I divided both sides by 2. So my time length is 100 seconds, but again, notice it asked me how many minutes. So I have to convert 100 seconds to minutes. To do that, I multiply by 1 over 60. 1 minute, minutes on top, seconds on the bottom, so the seconds will cancel. And I end up with 5/3 minutes. Well, if someone really asked me this question, how many minutes will it take Hope to overtake Quinn? If I said 5/3 minutes, I think they would think I was crazy. So in math, we do generally like improper reduced fractions, but if I'm going to give an answer to a word problem, a mixed number is more appropriate in this case. So 1 2/3 minutes will be the amount of time it takes Hope to overtake Quinn. So now it's time for you to practice more problems like this. So I have an assignment posted for you. Get started working on that, and whatever you do not finish, do for homework. Have a great day.